Hi, I'm Mukhlisur Rahman from Texas A&M University. Today I'm presenting our CVPR 2026 paper, MambaLiteUNet. This work was done with Dr. Sunggi Zhang from Kyungpook National University and Dr. Tracy Hammond from Texas A&M University. So, skin lesion segmentation is important for early melanoma detection. The lesion boundary shape texture can provide clinically meaningful information, but in real dermoscopy images, the lesion region is often hard to separate. Lesion can have different colors and shape, hair artifact, low contrast can also hide the true boundary. There is also a practical trade-off. So larger models can be accurate, but they are very expensive. And light, on the other hand, lighter models are efficient, but they can lose fine boundary details. So our goal is to build a compact model that can preserve lesion details, understand global context, and suppress background noise. To address this, we introduce MambaLiteUNet, a lightweight framework for robust skin lesion segmentation. The main idea is simple. We treat segmentation as an adaptive feature filtering problem. And MambaLite has three key modules: AMF, LGFM, and CGA. Together, these three modules improve accuracy, efficiency, and robustness. Here is the overall framework. And MambaLite follows a unit-style encoder-decoder design. The encoder extract feature at different resolution. The decoder reconstruct the final lesion mask. The key difference is how the feature are refined. AMF gives the model multiple Mamba-based view of the lesion. LGFM connects find local texture with global structure, and CGA clean the skip connections so the decoder receives more useful lesion information. In simple terms, the model first collect useful pattern, then mix with local and global information, and finally filters the feature before producing the final mask. Now look at the quantitative result. Across 4 dataset, MambaLiteUNet achieves strong average performance, and at the same time it uses only few parameters and GFLOPs, and this shows that our model is both lightweight and highly accurate. Now let's look at the qualitative result. Compared with other lightweight models, MambaLiteUNet produces cleaner mask and more stable lesion boundary. The red outlines show errors from other model. Many baseline either miss lesion or include background areas. Our model follows the lesion contour more closely. The plot summarizes the accuracy efficiency trade-off. The ideal position is the top left region. The main difference with other models, it give the high accuracy but take very less parameter and GFLOPs. And we also perform extensive ablation studies to finalize our model, and we analyze the effect of each core modules, branch number, channel configuration, input size, and loss function. And finally, we found that 4 branches, 3 channels, C3 channel settings, 256 by 256 input size, and binary cross entropy loss and dice loss give the best overall balance. And the feature visualization shows how the model learned. With our modules, the feature map focuses more clearly on lesion relevant region. The stage-wise visualization also shows a clear progression. Early decoder layer capture local pattern, deeper layer capture more abstract structure, and overall the model gradually move from raw image feature to clean lesion prediction. And we also evaluate generalization. MambaLite perform well when trained on ISIC 2018 dataset and tested on PS2 dataset. We also tested beyond dermoscopy on ultrasound and histopathology dataset. This shows that the learned representation is not limited to one dataset or one imaging condition. And we further evaluate domain generalization on HAM10K dataset. HAM10K includes 7 lesion types. For our case, we only test train on NV classes and tested on the other lesion classes, and this shows that it remained robust, like when the test lesion types are different from training class, And it is very important because clinical data often contain rare and unprecedented lesion types. And we also evaluate practical efficiency at 256 by 256. A resolution with best size 1 MambaLiteUNet keeps memory uses low and maintain competitive inference speed. We also test data efficiency using 50%, 70%, 100% training data, and the model remains strong even with reduced training data. And this is particularly valuable because medical annotations are often limited. And to summarize our key takeaways, MambaLite achieves SOTA segmentation performance with lightweight framework, and it introduces three novel modules: MF, LGFM, and CGA. And finally, MambaLite is, we can say that MambaLite is the first lightweight and has a strong deployment potential. And our code and appreciate models are public level. Feel free to use those. And thank you for your time.